In this demonstration, I'll show you how to use trigonometric functions to solve any right triangle. The trigonometric functions are sine, cosine, and tangent, and they are designed to compare different side lengths. For example, sine compares the length of the opposite versus the length of the hypotenuse. Cosine compares the adjacent over the hypotenuse, and finally tangent compares opposite over adjacent. And it really helps to memorize this acronym, SOHCAHTOA, when it comes to solving these right triangles. Let's start off with the first example. In this example, we are asked to determine the length of P in the triangle MNP. So what we have here is we have the length of the hypotenuse, which is the side that is across from the 90 degree, and we are also given an angle of 60. The length in question is the opposite. So this is what we're looking for, and relative to this angle, it is the opposite of this angle. So pretend that this was an eyeball looking this way. That would be the opposite. That being said, what pieces of information do we have? Well, we have an angle, which I'll denote as theta. I'm going to use this symbol to denote angle. And we've also been given the hypotenuse at 225. So it really helps when it comes to tackling these questions to write out everything that you've been given. So we know the angle, we know the length of the hypotenuse, and we're looking for the opposite. What ratio, SOHCAHTOA, will help us determine the opposite? Well, we're going to need a ratio that has opposite, and this both have opposite. And we also need to pick the ratio out of these two, the one that also incorporates hypotenuse, because that's the angle that's the side that we've been provided. And this seems to fit the spot. So we're going to use sine. Sine theta, this is where the angle goes, is equal to the opposite over the hypotenuse. The opposite is what we're looking for, and it's denoted as the letter P, so I'm just going to write down P in place of opposite. The hypotenuse is 225, and there's no need to put units when you're solving the question. And finally, sine, we're going to replace this theta with the angle that they've given us, sine 60. Next, we'll solve for P, and for most students, this is the hard part. The way you solve for P is first, you will multiply both sides by 225. This is the same thing as cross multiplying, if that's what you're familiar with. If you multiply both sides by 225, you'll notice that there's a 225 at the top and one at the bottom, and that cancels them out. So we're left with 225, and this little dot here denotes multiply. 225 times sine 60 is equal to P. Let's use our calculator to finalize this. 225 times sine 60, and it's important that you make sure your calculator is in degrees, and we end up with a side length of 194.85. P is equal to 194.85. We're using feet, so make sure that you conclude with the unit. Wonderful. Let's move on to the next example. Here we are asked, which primary trigonometric ratios can you use to calculate the length of the indicated side? Find the length of E. Let's start off by writing out SOHCAHTOA. SOHCAHTOA. And the reference angle that they've provided is 25. Now, if you want to use this as your reference angle, feel free to do that. You're just going to need to solve for it, but I would suggest using the one that has been provided, because chances are you might make a mistake finding this, and although your process is right, the answer in the end can be incorrect. So 25 is the reference angle, and we're looking for E, so that's once again the opposite. And we've been provided the hypotenuse. That's the hypotenuse. And O and P, O, opposite, and H would be sine. But since we already use sine, let's change this up a little bit. How about we say we're looking for the adjacent. Let's say we're looking for this. Let's call this one E. And and we've been given the opposite. Let's say the opposite is 4.5 meters. That being said, let's try to figure this one out instead of the original, because the original modeled the one above. So we have the opposite, we don't have the adjacent, and that's what we're looking for. We've been given the reference angle, so theta is equal to 25. We've been given the opposite of 4.5, and we're looking for the adjacent, which we'll denote as E. Which of these three would fit this criteria? Well, we have an angle, so all three of these would work so far. We've been given the opposite, and we're looking for the adjacent. That means we would need tangent. Tangent, angle 25, is equal to the opposite over the adjacent. Our opposite is 4.5, and our adjacent is E. Now, a lot of students run into this situation where the unknown is at the bottom. Now, if you ever run into this situation, don't worry. Do the exact same thing you did above. Remember above when you multiplied both sides by 225? You tried getting rid of that denominator? Well, we're going to do the same thing here. Multiply both sides by E. Now, if you've done this in a different way, feel free to use the same method that you are comfortable with. But for this example, we'll use this method. So if you multiply both sides by E, notice the E at the top and the one at the bottom will cancel out. And you end up with tangent 25 times E is equal to 4.5. And you're going to use some simple algebra here to isolate for E. The way you would do that is you divide both sides by tangent 25. That destroys that one. And whatever you do to the left side, you do to the right. And you're left with E is equal to, let's figure this out on our calculator, 4.5 divided by tangent 25 is equal to 9.65 meters. So there you have it. That is how you use trigonometric functions, SOHCAHTOA, to figure out unknown lengths in right triangles. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.